This video is for a scientific notation tutorial, so you only need to watch this if you don't know or don't remember how to write numbers in scientific notation. We will be using scientific notation throughout this course, and so you can always refer back to this if you need to. This tutorial is only going to be addressing how we write numbers in scientific notation. When it comes to how we do calculations with them, we will be going over that in class as we come to it, and I will show you how to put it into the calculators that we use in class. So let's get started. So we will only be using scientific notation for really big numbers and really small numbers. And so an example of a really big number would be 4,500,000 would be an example of a big number. And then an example of a small number would be something like 0.00000078. And so to make these numbers easier to deal with, we would be putting these into scientific notation. Okay, so let's talk about how we would turn a very big number into something with scientific notation. So when we have a really big number like this that does not have a decimal, of course we assume that the decimal is here at the end. So we're going to assume this decimal is here. And then we are going to move the decimal until we have one non-zero number in front. Only one non-zero number in front. So we're going to take that decimal and we're going to say we're going to move it 1, 2, 3, 4, 5, 6 times. So we would now write this number as 4.5, and then however many times we move the decimal, we're going to write times 10 to that many times, and we said that was 6. So this number would be 4.5 times 10 to the 6. And so we can write that number without having to put so many zeros. Anytime we have a number that is greater than 1, our our exponent will be positive. So if our number is greater than 1, when we're moving it, we will have a positive exponent. Okay? So now let's look at the next slide and see how we turn a really, really small number into scientific notation. All right, when we are moving a number that is less than 1 into scientific notation, it is still a similar concept, except now we're going to have a negative exponent because we are moving it into a number that is less than 1. So in this case, I already have my decimal here, and I'm going to still move the decimal until I get to a point where there's one non-zero number in front. And so in that case, that's going to be the 7 and the 8. So I will move this decimal until I get it right here between the 7 and the 8. That way I have one non-zero number. So I will take this decimal and now I'm going to count. 1, 2, 3, 4, 5, 6, and 7. We moved it 7 times to get to that place where there's one non-zero number. So I know I'm going to be 7.8. Still going to have the times 10, and I'm still going to put the number of times I moved it, but because I went into a number that is less than 1, or I moved it to the left, this time I'm going to have a negative exponent. So it would be a negative 7. Anytime you're looking at scientific notation, if it is a positive exponent, it's going to be greater than 1, so it'll be a bigger number. If I have a negative exponent, it's going to be smaller than 1, so I'm going to have a decimal with lots of zeros in it. Okay, on the next slide, we're going to do a couple of examples to see if you understand the concept. So here, let's practice with some really big numbers. We're going to do the first two together, and then I want you to pause the video. You try to do the next two and then start the video again to see if you got them correct. So we're going to start with the 125,000. Remember, we are assuming the decimal is at the end, and so we're going to put our decimal here, and we're going to say, okay, we're going to move it, and we're going to say 1, 2, 3, 4, and 5. Remember, we stop when there is one non-zero in front. So we would say that this is 1.2 25 times 10 to the 5th, because we moved the decimal 5 times. Now notice, if it was a non-zero number, I included it when I wrote the scientific notation. The zeros, because there's not a decimal there, I can leave off for right now. If there was an actual decimal there, we'd have to do that a little bit differently, but we'll talk about that in class. So for this purposes, if there's not a zero and we're assuming it's there, we can drop those numbers off when we put it in scientific notation. So now let's do the next number. So I assume my decimal's here, and I say I've got to move it 1, 2, 3, 4, 5, 6, 7, 8. So I would write this as 4.58 times 10 to the 8th. Okay? So at this point, I want you to pause the video, you write down what you think the number is, and then start the video and see if you got it correct. All right. The first example that you did by yourself should have been 1 times 10 to the 3rd. And then the last example should be 3.4789 times 10 to the 11. Remember, when we are writing in scientific notation, we have to include all the non-zero digits. Okay? All right, so on the next slide, let's try some smaller ones. All right, now let's try some more of those smaller numbers. So again, we'll do the first 2 examples together. Then I want you to pause the video, and then you try to do the second 2 examples by yourself. So we're going to move our decimal until we have one non-zero number in front of it, okay? And because we are moving it into a number that is less than 1, this is going to be a negative exponent. So anytime I see a bunch of zeros in front of a non-zero number, like in this case, I need to remember it's going to be a negative exponent. So let's start counting. We have 1, 2, 3, 4, 5, 6, 7, 8, and 9, because we stopped there. So we have 9. Now, since there is no other number behind that 1, it would just be 1 times 10 to the negative 9 is how we would write that. Okay? Now let's do the next one. Again, we're moving it to where there's one non-zero digit in front of the decimal. So I'm going to take this and say 1, 2, 3, 4, and 5. And so I would include all of those non-zero numbers of 4.86 times 10 to the negative 5. Okay? So pause the video and try the next 2 by yourself. All right, how'd you do? Hopefully you got those correct. If you are still having trouble understanding this, then you definitely need to come in for tutorials or go on YouTube and try to watch some videos over scientific notation. Remember, when it comes to doing math with them, we're going to go over that in class, and I can show you how to put it in the calculator. So, like I said, if you're still struggling, go ahead and come in or watch yourself some videos. Now stay tuned for the next slide for the jokes. Okay, first joke. Why can't you trust stairs? Because they are always up to something. Next one. Why did the football coach go to the bank? To get his quarterback. All right, see you in class.